Okay, the solutions for quiz 6. Okay, first question asks for the critical numbers of a function and the intervals over which the function is increasing and decreasing. So to find critical numbers, we take the derivative of the function, which is 4x to the 3 minus 6x squared, and we look for x values that cause the derivative to be 0 or the derivative to not exist. Now this is a continuous function. There's no problems with the derivative not existing, but we can find the x values that make the derivative 0. Okay. The best way to solve questions like this, when you're looking for an x value that makes a situation true, is to common factor. So I'm going to common factor 2 from both pieces and x to the 2 from both pieces. The first part, what I'm left with is there's a 2 left over, and there's a single power of x, and for the second part what's left over is a negative 3. And we want the x values that make either parts here equal to 0. So from the first part, we can make that part 0 if x is 0. And for the second part, we can make that part 0 if 2x minus 3 is 0, which means 2x is equal to 3, which means x is equal to 3 over 2. So those are our critical numbers. At x is equal to 0, and x is equal to 3 over 2. Next, we're going to look for regions of increasing and decreasing, and that's going to require us to draw out a number line. So my number line goes from, well, I think I need a bigger number line. It goes from minus infinity to infinity. And we have to cut the number line at the two special numbers we found, the two critical numbers, at 0 and at 3 over 2. Just make sure you put the smaller number at the left, larger number to the right. Then we want to test, is the derivative positive or negative in each of the three regions that the number line has been subdivided up into. In order to test that, the simplest way is to find any number that's inside each of the three regions. So the first region goes from negative infinity to 0. You can pick any number in there. I'm going to pick negative 1. Second number goes from 0 to 3 over 2. So I'm going to pick 1 because 1 is bigger than 0 and it's less than 3 over 2. And then to the right of 3 over 2, I'll pick 5 because that's definitely bigger than 3 over 2. Although you could pick 2 as well, and that's safe. Okay. Next part is what you do with these test values is you plug them into the first derivative. So f prime of negative 1, that's going to be, I'm going to plug it into the factored form, 2 times negative 1 squared times 2 times negative 1, so negative 2 minus 3. So that's going to be positive times negative, which is negative. And that means the function is decreasing in the first region. Now we check the second number. Second test value f prime of 1, that's going to be 2 times 1 squared times 2 minus 3. And that's going to be positive times negative, which is also negative. So in the second region, the function is also decreasing. I think this caused some grief in the quiz that you have two regions side by side. They don't switch, but it's fine, it happens. Last region, f prime of 5. That's going to be 2 times 5 all squared times 2 times 5, so 10 minus 3. Notice that in all these calculations, we're just trying to find out if the outcome is positive or negative, not what the actual value is at these arbitrary test points that we chose. First part, positive. Second part, positive. So we get an overall positive answer, which means increasing. Now, that's all the question wants. It just wants regions of increasing and decreasing and critical numbers. So the graph answers the question that the function is increasing only from 3 over 2 up to infinity, and it's decreasing everywhere else. If it asks about max or min, we would say that there's a min at x equals 3 over 2, and then we would then struggle mightily to get the y value by plugging x is equal to 3 over 2 back into the function. Okay, next part. Question 2 asks for the relative extrema of the function. So we have to start the same way. We have to look for critical numbers. We do that by taking the derivative and setting it to 0. So we get 3x squared minus 12x, and then the 15 vanishes. Derivative of a constant is 0. Now we set the derivative to 0 and solve for x. So 3x squared minus 12x. Do the same thing as before. We common factor. And this time we're going to common factor a 3 out and an x to the power of 1 out. From the first piece we're left with an x. From the second piece we're left with a 4. Rather negative 4. And we want to set that equal to 0 and solve for x. For the first part, that part 0 if x is 0. And for the second part, that part 0 if x is 4. So those are our two candidate locations for max and min. Now we draw a number line. Number line goes from minus infinity to infinity. We cut the number line at 0 and at 4. And we have to make test values again. So the test values, again, any number inside each of the regions that have been defined. The first region goes from negative infinity to 0, so I'll pick negative 1 as a number that definitely fits into there. Second region goes from 0 to 4, I'll pick positive 1 as a number that fits in there, and the last region goes from 4 to infinity. I feel like picking 10, just because. Now we're going to plug the test values into the first derivative, f prime at negative 1. That's going to be negative 3 times negative 1 minus 4. That'll be negative times negative, which is positive. And that means the function is increasing inside that first region. Now we do the same thing for the second test value. We plug positive 1 in. We get positive 3 times 1 minus 4. That's going to be positive times negative, and that's negative. That means decreasing in the second region. So already we can tell there's going to be a max at 0. But we won't do that step yet. We'll do the interpretation step at the end after plugging in all the test values. So our last test value I'm going to plug in is 10. And viewers at home, you may have picked 7 or 5, and it won't change the outcome. So we have 30 times 10 minus 4, which is positive times positive. So the outcome, the part that matters, is whether or not the derivative inside that region is plus or minus. Oh no. Okay. So increasing in that region. Okay, so we're close to being able to conclude. We can tell that there's a max at 0 and there's a min at 4. So I'll state that there's a max at x is equal to 0. Let's find the y value. Y is equal to 0 cubed minus 6 times 0 squared plus 15, which is 15. So that's plugging the x value into the original function. That's how you always get with the y value. And then there's a min at x equals 4. This isn't going to be very fun, but it's okay. Y is equal to 4 to the 3 minus 6 times 4 squared plus 15. So that's going to be 64 minus, oh no, 6 times 4 times 4, what is that, 96 plus 15. So 64 plus 15, that'll be 79 minus 96. So let's see, 73. negative something, negative, you see I'm bad at subtraction. My brain doesn't work right. 26, negative 20, is that negative 17? I'll just go with that. So 17 plus 79, yes, okay, that's good. So that's our xy coordinate at that minimum value, at the location where there's a minimum. And these are local minimum. There are any locations that look like tops of hills or bottoms of valleys, and that's contrasted against the next type of max and min, which is called an absolute max and min. And these are done in a completely different way. So for question like number 3, you do not make a number line, but you do start the question out using the same process, which is look for critical points. Look for candidate locations where you could have max or min. So we take the derivative set equal to 0. F prime is going to be 3x squared minus 6x. Set it to 0. So again, we common factor. I'm going to take a 3 out and an x out from both pieces. Left with an x minus 2 as leftovers. We set both to 0. So we get from the first part, 3x will be 0 when x is 0. From the second part, x minus 2 will be 0 if x is equal to 2. And there is no number line. Those are our two candidate locations for extrema, for absolute max and absolute min. With two more. We have to check negative 1. And we have to check x is equal to 3. Because the absolute max and absolute min of a function on a closed interval could occur on the endpoints of the interval. Now the way we proceed from here is we check each of these candidate locations. So I'm going to circle them. We're going to check all 4. And what we're going to do is we're going to compare the y values of f of x at these x values, at these candidate locations for global max and global min. So it could be that the global max and min are at the endpoints of the interval, or it could be that the global max and min are in the middle at a local max or local min. The only way to find out for sure is to get the y values. So we're going to do f of 0. That's going to be 0 to the 3 minus 3 times 0 squared, which is 0. Now we'll do f at 2. That'll be 2 to the 3 minus 3 times 2 squared. That's 8 minus 12, which is negative 4. Now we do the first endpoint, f of negative 1. That's negative 1 to the 3 minus 3 times negative 1 squared. So that's going to be negative 1 minus 3, which is also negative 4. So that looks like a tie, unless this one's lower, f of 3. So that'll be 3 times 3 squared minus 6 times 3. So 27 minus 18, which is 9. Now, we're almost done. The next step is to make a statement about what this means. The lowest y value is our global min. So there's a tie. Two comma negative 4 and negative 1 comma negative 4. And then the global max, we have 1. There's no tie. It's just global max at the coordinate 3 comma 9. Okay, now the bonus questions. First bonus question was asking about x coordinates of relative extrema, which relative extrema is a fancy word for max and min. It's already occurred a few times in the quiz. And they give you a function 4x to the 5 minus 5x to the 4 minus 40x to the power 3, and then they tell us what the derivative is, and in beautiful factored form. To find the relative extrema, we set f prime equal to 0. So 0 is equal to 20x squared times x plus 2 times x minus 3. And we look for all the critical numbers, so here we get 3 of them. First comes from the first term being 0, that's if x is 0. The next one comes from the second term being 0, that's x is equal to negative 2. And then finally, x is equal to 3 from the third term being 0. Now we have to, because it's a relative extrema, not global, so that's a very important difference, we have to make a number line. So we go from minus infinity to infinity. We cut the number line at all 3 spots, at negative 2, at 0, and at 3. And now we have lots of regions to check. We have 4 regions, so I'm going to pick a number in the first region from negative infinity to negative 2. I'm going to pick negative 10 because I feel like it. You can pick negative 3 if you want. From negative 2 to 0, I'm going to pick negative 1. From 0 to 3, I'm going to pick positive 1. And then from 3 to infinity, I'm going to pick 5. Or 4, or 10. Doesn't matter. Now we do the same thing we did before with the number line stuff, is we plug the test values into the spot that gave us the critical numbers, gave us the subdivisions. So in this case, we're going to plug it into the first derivative, f prime of negative 10. That's going to be 20 times negative 10 squared times negative 10 plus 2 times negative 10 minus 3. So let's look at all the signs that we got. We got positive, something squared is positive, and then negative 10 plus 2, that's negative 8, so that's negative, and then negative 10 minus 3, that's negative. So we get positive times negative, that's positive. Let's see, what haven't I used yet? I think I need a new pen. Get the golden color back. So we've got a positive. That means the function is increasing in the first region. Now we do the next test value. Plug that into the first derivative, f prime of negative 1, that's going to be 20 times negative 1 squared times negative 1 plus 2 times negative 1 minus 3. Put it all together, we get positive times negative. So this time we get negative. So the function is decreasing in the second region. Okay, right away we can say max at x equals negative 2. It looks like the top of a hill. Okay, next test value, f prime of 1. So that's 20 times negative 1 squared times 1 plus 2 times 1 minus 3. That's positive, negative, which is negative. So there is nothing special going on at 0. It's not a max or a min. Well, there is something special, but it's neither of those, not max, not min. Now the last test value, f prime of 5, that's going to be 20 times 5 squared, which is positive, times 5 plus 2, which is positive, times 5 minus 3, which is also positive. So we get 3 positive things all multiplied together, which is positive. Aha, and that's a min. It goes down and then back up at 3. That means there is a min at x equals positive 3. And it doesn't ask for the y coordinates, just the x coordinates. So enough work as it is. Okay. Next question. Determine the regions where this function is increasing and decreasing and finding the xy coordinates of local max and min. So here we go. We're going to take the derivative of the function. I'm going to rewrite it up above. We have x squared plus 4x plus 9 to the power of 1/2. When you take the derivative, this is a chain rule, w to the 1/2. So the 1/2 comes down. We have the original function, x squared plus 4x plus 9 to the negative 1/2, multiplied by the derivative of the inside, which is 2x plus 4. I can rewrite this. This is 2x plus 4 on top, and the 2 downstairs from the 1/2, and then that power negative 1/2 around the x squared plus 4x plus 9, that's a square root. The fact that it's negative means it's a square root downstairs. Okay, and then you can common factor the 2 from the top, and then divide the 2 by the bottom, and you're left with x plus 2 over the square root stuff. Okay, and this was the one that I think I mentioned in class, that one of the bonus questions was hard. It was this one. One of the challenges is when you look at the denominator, you may be worried that the denominator could possibly be 0, and then you'd have an extra critical number that comes from there. But if you try to factor it, you try to look for when it's 0, you'll find that it doesn't have any solutions. It's the bottom can never be, the interior of that square root function cannot be 0, because the discriminant b squared minus 4ac, if you think back to a quadratic formula, that discriminant is negative. So you don't have to worry about that. You only have to set the first derivative equal to 0. So 0 equals x plus 2 over the square root stuff. Cross multiply, 0 times square root stuff equals x plus 2. 0 times anything is 0, so 0 is equal to x plus 2. That means x is equal to negative 2. That's our one candidate location where we could have a max or we could have a min. Now we make the number line. Our number line goes from minus infinity to infinity, and we're cutting it at negative 2. We have two regions. We have to choose a test value in each one. So I'm going to pick negative 5 for the first test value, something less than negative 2, and I'm going to pick positive 5 for the second one. And what we do is we plug that into the first derivative. So f prime at negative 5, that's negative 5 plus 2 over the square root of 25 minus 8 plus 9. That's something negative upstairs divided by something positive downstairs, which is negative. So the function is decreasing in the first region. Now f prime at positive 5, we get positive 5 plus 2 divided by the square root of positive 5 squared, 25, plus 4 times 5. Oh, did I multiply? Oh, that 8 shouldn't be an 8. Sorry about that. That 8 should be negative 20. My mistake. I put a 2 instead of a... Okay, so then here we have positive 20 plus 9. So we get something positive upstairs divided by something positive downstairs, which is going to be positive. So it's increasing. That means that there is a max. Not max, there's a min. Going down and back up, so there's a min at x equals negative 2 and y equals f of negative 2, which is the square root of, let's see if this can be squeezed in here, we get negative 2 squared, so 4, and then plus 4 times negative 2, so negative 8, and then plus 9, so that'll be the square root of 5, which doesn't square root nicely, you just have to leave it alone. That's it for that bonus question. Pretty nasty. Okay, then the last one, this isn't that bad. Looking for the global maximum, global minimum of a function on an interval. So we have x values to check. We have to check x equals -2. We have to check x is equal to 0. Those are given to us as endpoints, and we have to check locations where the first derivative is 0. Now the bottom of the first derivative is never 0. We don't get critical numbers from that, but the top being 0. Cross multiply, x squared plus 1 all squared times 0 is going to be 0. So we have 0 is equal to 5 times 1 minus x times 1 plus x, which is going to be 0 if x is 1 or if x is -1. However, we don't use both of them because that first one, x is equal to 1, is not inside the domain. So it doesn't count. We'll only check -1. So we check -2, 0, and -1. Here we go. Here's our check. Plugging into to get the y values at these x values. So to get the y values, we plug them into the original function, f evaluated at -2. That's going to be 5 times -2 divided by -2 squared plus 1. That'll be -10 over 4 plus 1, -10 over 5, which is -2. Now we're going to plug in 0. So that'll be 5 times 0 over 0 squared plus 1. That's 0 divided by 1, which is 0. And the last one, f at -1, we're going to have 5 times -1 over -1 squared plus 1. That's -5 divided by 2. Now you have to think about how -5 over 2 compares to -2. So to do a good comparison, you can bring it to common denominators, or you can decimalize. You could decimalize -5 divided by 2 as -2.5, or you could common denominator the -2 to write it as -4 over 2. And the -5 over 2 is more negative. So that's your min. Global min at -1, -5 over 2. And then the most positive number, most positive y value is at 0. So global max at 0, 0. That's the answer for that bonus question. And that's it for the quiz.